All right, so here we're looking at simple truss problem question number 3. A little more interesting with the box rectangular frame there. But still, we've got member A, B, and C. Save some time from the previous two videos. We're going to put those reaction forces of A being the roller of 1 force and the pin being 2. We're going to take B as the pivot point, and we're going to look at then the force of member or the moment at A and the moment at B. Why aren't we using the one in the top right corner? There's no force there, so 0 is times anything is 0. It's going to cancel out for us. So A is 2 units away from B, and we don't know that reaction force in the x direction. C is 1, 2, 3 units away from B, and its force that's given to us is 100. So 300 divided by 2 gives us a reaction force of pin A, 150. Why is it pulling to the left? Well, C is pulling clockwise, so therefore A needs to be pulling counterclockwise to fight that rotation between the two. So then sum of all the forces in the x direction needs to equal 0. So therefore the force at B in the x direction needs to be 150 going to the right. And therefore also that y direction at B needs to be 100 going up to counteract and fight with that other force at C that's going down. So if we look and isolate at pin B, we've got to find the member AB, and we've got to find the member BC. Why do we start at B? There's no angles. Let's stay away from angles for as long as we can and find some simple stuff, because we know the sum of all the forces in the x and the sum of all the forces in the y needs to equal 0. So what do we have? Well, all the x's needs to equal 0. So if we calculated 150 to the right from the moments, that means we've got to have 150 to the left for FBC, and we've got 100 up from the moments, therefore we've got to have 100 down from the moments, so FAB's got to be 100, and everything is going to compress onto that point that's right there in order to get them equal. 150 to the left, the other one's got to be 150 to the right, everything's compressing on that. So now we've got to calculate AC. We'll work our way outwards. We've got to go and calculate AC, so we'll go to pin C. We could have went to pin A, let's go to pin C. What different things are interacting at C? Well, we have the given force of 100 units. We have member BC, which we know already, which is going in the x direction. We have member now AC, which we do not know anything about, but we do know it's at an angle. So any force that's at an angle, we get its two composites. We have its two composite vectors, one in the x direction, one in the y direction. And then we have this other member that's sitting out here, which is A, or C, we'll just call it CD, and we can calculate that one. So what do we know? Well, again, we know the sum of all the forces in the x direction needs to equal 0. How many forces in the x direction do we have? We have 2. We have 150 right, which means the other one's got to be 150 to the left. What else do we know now? Well, we've got a triangle sitting here. We've got 150 as one leg, and we've got an angle of 33.69. So what can we use? We can use some trig to calculate those other two values. So F, the force of AC in the y direction, if we want to calculate for that, that's the opposite of the angle. We know adjacent to the angle, so we're going to use the tangent of that 33.69. It's going to equal to opposite FACY over the adjacent 150. So we're going to take our 150, multiply it by the tangent of 33.69, and we're going to end up with let's see here, what do we got? Just pretty much 99.99. So we've got a nice looking 100 there. So we're going to plug that into our picture and try to keep on calculating and see where we're going. We know the sum of all the force in the y direction equals 0. So this one we've got 100 going up, since FAC is being shown and proven to be under tension, since the force of ACX is pulling away. So if we've got 100 up and 100 down, those cancel each other out. So what is FCD? That one's got to be 0. So now Pythagorean theorem to find that hypotenuse. One leg of 150, another leg of 100. 100 squared plus 150 squared gives us that tension force of 180 being applied to member AC on this structure. Look at that joint D. Sum of all the forces of the x is 0. Sum of all the forces of the y is 0. So if there's only one x or there's only one y, both of those have to be 0 for us.